The North American X-15 rocket-powered aircraft project is known for bridging the gap between human-crewed flight within and beyond the bounds of Earth. After successfully completing its initial test flights in the late 1950s, the X-15 became the first winged aircraft to reach the velocities of Mach 4, 5, and 6. The X-15 was also the aircraft used for the first official NASA mission after it absorbed NACA in 1958. But its most recognized mission was Flight Number 90. A test flight conducted in 1963 by NASA and the Air Force was the first of two missions expected to pass the 100-kilometer height of the Kármán line, set by the International Aeronautical Federation. Flown by pilot Joseph Walker, this flight suffered from a few interesting deviations from the original plan. But instead of ruining it, these unexpected divergences in the plan helped Walker ascend over the Kármán line and become the first U.S. civilian in space. It also turned the X-15 mission into the first spaceflight of a space plane in aviation history. In the 1950s, NASA's predecessor, the National Advisory Committee for Aeronautics, joined the Air Force and the Navy to create the X-Series program of experimental rocket-powered planes. The project, which began in 1954, had the main objective to push all aviation boundaries. Its most ambitious prototype was the X-15, a hypersonic rocket-powered aircraft expected to fly as fast as Mach 6 speed and at peak altitudes of at least 46 miles. In the book X-15, Extending the Frontiers of Flight by Dennis Jenkins, the plane is described as a, quote, airplane of accelerations. When an X-15 pilot looks back on his X-15 flights, it is the accelerations he remembers. The plane had a length of 50 feet and a mass of about 33,300 pounds at launch. It also had a pair of low aspect ratio trapezoidal-shaped wings that spanned over 20 feet. Based on NACA research, the X-15 was implanted with a set of wedge-shaped vertical stabilizers and thinner, down-pointing horizontal stabilizers to provide directional control during flight. These stabilizers gave the aircraft its signature arrow-like look. The X-15 was powered by an XLR-99 engine that burned through 19,000 pounds of liquid anhydrous ammonia and liquid oxygen held in its propellant tanks. If the plane was flying too high, and the air was too rarefied for its aerodynamic controls to work correctly, the X-15 relied on a set of small hydrogen peroxide-fueled jets installed on the nose. Wingtips with thrusts of 180 and 450 newtons also aided in attitude control. The first X-15 made its first unpowered glide flight after being dropped from its carrier on June 8, 1959. This achievement was followed by the first powered flight of a second prototype on September 17th. On November 15, 1960, the aircraft took its first ever powered flight with an XLR-99 engine. The third aircraft, X-15-3, made its inaugural flight on December 20, 1961, with NASA civilian pilot and future legend Neil Armstrong at the controls. In its lengthy operational period, which ran from 1959 through 1968, the X-15 completed over 100 flights. Its performance expectations kept expanding to ever higher speeds and altitudes. The flight missions usually began early in the morning, as most flight testing at Edwards Air Force Base did, when the temperature and wind in the high desert are lower. On Flight 52 of the program, which occurred on April 30th, 1962, a NASA test pilot flew the X-15 to an altitude of 237,600 feet, achieving its original design goal height. Flight number 63, in July of that same year, broke yet another record of altitude. This time, USAF's Robert White piloted the X-15 to a height of 311,520 feet, which prompted the Air Force to grant White his certification for astronaut wings. All these successful missions led the engineers of the X-15 to seek more records to break. The aircraft was still capable of more astounding achievements. The directors of the X-15 program had high expectations for flights number 90 and 91. To test the X-15's limits while still leaving a safe margin to avoid possible hardware performance, they decided to fly the plane in 2 successive missions at an altitude of 360,000 feet. This way, the plane would fly above the Kármán line, an imaginary barrier set up by the International Aeronautical Federation to establish a boundary between Earth's atmosphere and outer space. The Federation defines the Kármán line as the altitude of 100 kilometers, or 330,000 feet above the Earth's mean sea level. Pilot Joseph A. Walker was chosen to achieve missions number 90 and 91. He first joined the Army Air Forces during World War II, where he served as a weather reconnaissance pilot. He later joined NACA after the war as an experimental physicist and eventually became a civilian test pilot. In 1951, Walker was moved to the Edwards Flight Research Facilities, where he was promoted to chief research pilot. As such, he flew an extensive array of aircraft such as the Bell X-1, 2 versions of the Douglas D-558 Skyrocket, the Douglas X-3 Stiletto, the Northrop X-4 Bantam, and the Bell X-5. In 1958, Walker joined the X-15 program when NACA was absorbed into NASA that same year. Walker's first milestone came when he flew the X-15 for the first time on March 25, 1960. This became NASA's first ever mission. By the summer of 1963, the pilot had already flown the aircraft 23 times. For flight number 90, Walker was set to equalize pilot Robert White's records. The X-15 engine would burn for 83 seconds to achieve its peak speed of Mach 5.4 and a total altitude of 314,961 miles. During the mission, Walker would deploy a special balloon on the end of a line to measure air density while other experiments were being performed simultaneously. These experiments included using an ultraviolet photometer to measure Earth's backgrounds and an infrared photometer to measure the aircraft's exhaust signature. On July 19, 1963, flight number 90 began just like every other X-15 mission, with a takeoff from Edwards Air Force Base. The plane was attached under a modified B-52 bomber's wing at 10:19 local time and surrounded by several chase aircraft. Following the release from the carrier aircraft over Smith Ranch Lake, Walker fired the plane's rocket engine, and the X-15 started to climb. In contrast to the plan, the plane's engine fired for 84.5 seconds instead of 83. This unpredictable device began to swing towards slightly higher performance. Flight number 90's ascent trajectory also turned out to be 0.5 degrees steeper than planned. As a result of these small but essential deviations, the X-15 exceeded all expectations and hit a speed of Mach 5.5, or 3,710 miles per hour. Even more importantly, the aircraft also overshot its planned ceiling for the mission by 31,200 feet. Because of this, its trajectory peaked at 347,800 feet. Technically speaking, Walker had unwittingly entered space and became a space pilot aboard his X-15, becoming the first civilian in space. After 11 minutes and 25 seconds in free flight, Walker piloted his X-15 through re-entry and safely landed on Rogers Dry Lake at Edwards Air Force Base. Following the success of mission number 90, the program's engineers prepped for the second flight that would continue to test the limits of the X-15, this time with a flight altitude of 360,900 miles. For mission 91, the engine would burn for 84.5 seconds and reach a top speed of Mach 5.38. But over the course of 2 weeks, 3 launch attempts had to be aborted. On August 3rd, the flight was called off due to weather. A week later, problems with the X-15's auxiliary power unit halted the mission. On August 15th, there were problems with both the weather and the auxiliary power unit, as well as an additional issue with a malfunctioning radio. Flight number 91 finally took off on August 22nd, 1963. After a 2-minute climb, the X-15, again with Walker at the controls, hit yet another record. This time, the X-15 reached an altitude of 354,199 feet, only a couple thousand feet shy from their goal, but sufficient enough for the mission. Walker piloted the X-15 through re-entry and landed safely on Rogers Dry Lake. After Flight 91, pilot Joe Walker became the first person to fly into space twice. It would be more than 40 years before another rocket-powered aircraft would beat the record. After his record-shattering mission, pilot Joe Walker left the X-Series program for other projects. Sadly, Walker's life ended in a tragic accident on June 8, 1966, when his F-194 aircraft crashed into an XB-70 Valkyrie bomber during a formation stunt and flight show during a publicity photo shoot. As for the X-15, the program continued for more than 5 years after Flight 90 and flew an additional 108 missions. Additionally, 8 of said flights helped qualify 5 more pilots for their astronaut wings. One of these risky missions claimed the life of a pilot aboard the third X-15. On November 15, 1967, USAF test pilot Michael Adams perished when his aircraft tore apart during a botched re-entry while descending from a peak altitude of 50 miles. Michael Adams was awarded his astronaut wings posthumously. The X-15's 200th flight never came to be after being delayed several times due to a plethora of technical problems and bad weather. It wasn't destined to fly into space again. The program was canceled officially on December 20th, 1968. In 1965, when two cosmonauts landed back on Earth in the snow-covered forest of Russia's Ural region, they feared their simple pistols wouldn't be enough to fight off the giant bears or hungry packs of wolves that roamed the area. Although the men survived the experience without coming across any animals, the concern remained. How would cosmonauts better protect themselves in case they landed in a dangerous place? That's how the primary survival weapon for Soviet cosmonauts, the TP-82, came to be. Created in consultation with a former cosmonaut, the weapon was designed specifically for the harsh environment in Soviet territory, not for fighting Americans. According to documents and interviews of former cosmonauts, it was used by space explorers for almost 20 years. Dozens of astronauts visiting the International Space Station have practiced with it. Few have even spoken publicly about it. Even though it's an open secret, to this day, the Russian Federal Space Agency still refuses to talk about the weapon. But in case there's any doubt about the TP-82's existence, there's one on display in a Russian history museum. Some in the American space program during the Cold War remain skeptical of its stated non-combat purpose. Back in the Cold War era, and before the space shuttle program, crews required a protective shell that could shield them during their re-entry to Earth. For example, the Apollo program crews were protected inside capsules that dropped into the ocean and were later retrieved by the Navy. But for the Russians, the story was different. In the 1960s, the Soviet space program created the Soyuz, their own series of spacecraft mounted on a rocket. Their preferred method of re-entry was also aboard a capsule. However, instead of splashing into the sea, it landed on Soviet territory. With over 8.5 million square miles, the Soviet Union was the largest country in the world. It was easy for a space capsule to get lost in such a large area. And that's precisely what happened to cosmonaut and Air Force Major General Alexei Leonov. In March 1965, he and crew member Pavel Belyayev participated in the epic Voskhod 2 mission aboard the Voskhod 3KD spacecraft, during which Leonov became the first man to ever complete a spacewalk. However, the task was riddled with errors from the beginning, and the spacecraft couldn't restore its center of mass for 46 seconds before re-entry. As a consequence, their capsule drifted way off course, 600 miles off the expected landing site. Although flight controllers had no idea whether Leonov and Belyayev had survived or not, their families were told that they were safe and resting. In reality, the men crash-landed in the desolate and snow-covered forest of Russia's Ural region. When it became clear to the men that they would not be picked up anytime soon, they geared up for their first night in this inhospitable forest. At the time of their mission, a Soviet cosmonaut's basic survival kit consisted of a simple Makarov pistol, a compass, matches, a machete, a fishing kit, strobe light, radio, medical kit, and wool clothing items. NASA missions also equipped their astronauts with a sharp machete, in the rare case of a jungle landing. Since both of the men were familiar with the taiga, a Russian word for snow forests, they carried their loaded guns and plenty of ammunition with them. It was mating season, and there was a large possibility that either bears or wolves could become aggressive with them. Thankfully, a Russian aircraft located them, but the area was so dense with foliage that helicopters couldn't land. The two cosmonauts had to spend the night in freezing 20-degree weather inside their capsule. A rescue party skied to their area the next morning, and they were able to light a fire. They spent another, more comfortable night in the area, and the following day, they skied down to safety. Leonev and Belyayev became a myth amongst Russian cosmonauts. The true survival tale is still talked about 55 years later, and rumors keep fueling the story. Some say that the men fought off bears, and that wolves scratched at their capsule's hatch. But the truth is, neither Leonov nor Belyayev encountered any animals. Only one of the rescue aircraft spotted and chased away a wolf pack, a couple of miles away from the escape module. However, this terrifying experience drove Leonov to advocate for a made-from-scratch cosmonaut survival pistol for future missions. Initial development for this specialty survival weapon began in the late 1970s, with Leonov's advice and a team of specialists in the popular Tula arms plant. The TP-82, which first entered service in 1982, was a triple-barrel shotgun that eventually became a staple of the Soyuz portable survival kit. According to rumors, the gun was also provided to various other Soviet Air Force units, especially for aircrews at risk of crash landing in other inhospitable regions. At first glance, the TP-82 looked like a large pistol. However, it was actually a convertible shotgun, meaning it was a double-barrel shotgun mated to a short-barrel rifle. Out of its 3 separate barrels, 2 of them were chambered for 40-gauge ammunition. The lower rifle barrel used the same rounds as the Soviet AK-74 assault rifle. The gun's buttstock was detachable to fit better inside the tiny Soviet space capsules. In addition, the device had a hidden blade that could be used as a machete to chop wood for fire and shelter. The weapon was powerful enough to deter a 1,000-pound brown bear and small enough to fit in the space capsule. Astronaut Dave Wolf, who spent a few months aboard the Mir Russian space station in the late 90s, agreed that the space weapon was, quote, a wonderful gun. I found it to be well-balanced, highly accurate, and convenient to use. After its design, the Soviet Union supplied all its missions with the weapon. It was first used in the Soyuz T-6 spacecraft in June 1982. From 1986 on, the TP-82 became a permanent staple in the survival aid kits of every mission. It was better to be safe than be unprepared when coming across a bear. The TP-82 weapon remained part of the Soyuz portable survival kit, used by international and multicultural crews until 2007. It was then publicly announced that all remaining ammunition stocks had become unusable, and the gun was supposedly withdrawn. But since spring 2011, when NASA decommissioned its space shuttles, all International Space Station missions use Russian Soyuz capsules. Although that custom-made gun reached the end of its shelf life, the survival kit still includes a Russian arm, likely the MP-443 or a Makarov pistol. The Russian Space Agency, however, doesn't acknowledge or discuss the use of the TP-82 or its supported successors. Before boarding the Soyuz to travel to space, astronauts go through extreme preparation. As part of their space education course, they're taught system and equipment maintenance, workstation organization, communication with mission controls, scientific research, and a hardcore crew safety training experience. It's said that astronauts of all nationalities, including American ones, also train with the TP-82. As part of their intense training, the astronauts have to complete a survival camping crash course in the Black Sea and the Siberian forest. They practice shooting and survival, all based in cosmonaut Leonov's Voskhod 2 story. But neither NASA nor the International Space Station has released any sort of footage of the training. The only available photographs of people using the guns for training are 2 private spaceflight participants who happily posed with the weapon in their hands. The only available model of the gun is in a Moscow museum. As of late, the International Space Station astronauts are leaving their pistols behind. According to an article by space journalist James Oberg for the IEEE Spectrum Science magazine, the crews nowadays are asked whether they wish to carry a weapon. Most of them say no. Mr. Oberg vehemently believes that no weapon should travel to space due to the astronauts' mental pressure in these critical missions. He suggested that, quote, presence of the gun, especially in light of recent space team psychological problems, might be an invitation to a future disaster. As more studies prove the impact a mission can have on astronauts, mental health has become a higher priority. Oberg believes that weapons should only be packed inside spacecraft in very unique circumstances. In his article, he proposed that a weapon should only be usable in case of an off-course landing, which was its original purpose in the first place. The journalist also said the gun should be stashed inside a closed compartment, only accessible from the outside of the Soyuz spacecraft, so the astronauts can only get to it after landing. However, Oberg's idea never received any conclusive answers. In this era, when GPS and satellite communications are more precise than ever, a situation similar to the Voskhod 2 stranding incident is highly unlikely, albeit possible. In 2008, a Soyuz capsule made a re-entry 250 miles off its original course. When Mission Control lost track of them, the crew was able to call them with a satellite phone, which is included in their updated survival kit. For almost an hour, this capsule, which carried South Korea's first astronaut, was off the grid. According to Oberg's 2014 article, the gun and ammo is still an official item on the personal survival kit of those astronauts who choose it, and while a standard pistol would not stop an angry bear attack, it might still be useful for other extreme survival situations. Even if the gun's real purpose is fighting off animals back on Earth, traveling to space with loaded weapons remains a touchy subject. The Russian satellite Cosmos 2542 was launched on November 26, 2019, on top of a Soyuz rocket. It then settled into orbit between 250 and 550 miles over the surface of the Earth. For almost 3 months, it stayed away from US satellites, but by mid-January it made an unusual move. As the satellite approached the $4 billion secret US spy satellite known by experts as KH-11, Cosmos 2542 remained close. Such a maneuver raised suspicions of alternate intentions by the Soviets, including a potential attack. As expressed by the commander of the US Space Force, John Raymond, quote, "This is all circumstantial evidence, but there are a hell of a lot of circumstances that make it look like a known Russian inspection satellite is currently inspecting a known US spy satellite." Less than 2 weeks after the Russian satellite Cosmos 2542 launched in November of 2019, it apparently split in two. US observers spotted what looked like a second, smaller satellite birthed from the original, just like a Russian nesting doll. The event was confirmed by December when the Russian Defense Ministry clarified, quote, "The purpose of the experiment is to continue work on assessing the technical condition of domestic satellites." However, Cosmos 2542 and its child, Cosmos 2543, seem to be carrying out a different mission. From January 20th to 23rd, they unexpectedly maneuvered to match their orbit with the KH-11, an orbital telescope staring down at Earth that was part of a reconnaissance constellation codenamed Keyhole or Crystal and operated by the National Reconnaissance Office, or NRO. Cosmos 2542 would initially pass the USA-245 satellite, as it was called by trackers, every 11 days, but there was much intrigue when the Russian satellite approached it. There are 2,200 active satellites in the world, more than half of which orbit between 100 and 1,200 miles above the Earth. It was clear that the Cosmos' real target was the USA-245. A Russian satellite shadowing a multi-billion-dollar US spy satellite could be a growing threat to the American superiority in space and potentially start a new and costly chapter in the never-ending competition between Washington and Moscow. The Russian Defense Ministry publicly stated, quote, "The satellite was created on the basis of a unified multifunctional space platform and can monitor the state of domestic satellites in orbit. Its optical equipment makes it possible to survey the Earth's surface." It is known that Cosmos 2542 is an inspection satellite, equipped with sensors and thrusters, but it has proven capable of positioning itself near other spacecraft and performing scans. Still, some Americans believe that some inspection satellites double as weapons and could tamper with or even destroy an enemy. The NRO operates 4 KH-11s, which orbit as low as 160 miles and as high as 620 miles, providing simultaneous wide and narrow surveillance by coordinating the orbits of the 4 satellites. Vast views of the Earth are shown in low resolution, whereas smaller pictures have better quality. Though the NRO doesn't comment on their operations, the school bus-sized satellites are easily distinguished from the ground. Michael Thompson, an American graduate student and amateur satellite observer, followed the events closely and tweeted, quote, "Cosmos 2542 is loitering around USA 245 in consistent view. As I'm typing this, that offset distance shifts between 150 and 300 kilometers, 93 and 186 miles, depending on the location in the orbit. That is a perfect distance for quality photos." Furthermore, it is public knowledge that KH-11s use the same type of lens as the Hubble Space Telescope, revealing the optical capabilities of the spacecraft. Thus, monitoring the spy satellite would be pointless. Russia has deployed several mysterious inspection satellites starting in 2014, as have the US and many other countries, such as China, Japan, and Sweden. In fact, the US Air Force's secretive X-37B robotic mini-shuttle might be the most famous spacecraft with inspection capabilities. And all of them have potential as weapons. Anatoly Zak, an independent expert on Russian spacecraft, explained, quote, "You can probably equip them with lasers, maybe put some explosives on them. If one comes very close to some military satellite, it probably can do some harm." Under that logic, the behavior of Cosmos 2542 could be perceived as a practice for war. Meanwhile, the commander of the US Space Force, John J. Raymond, disclosed that the Russian craft had begun its maneuvers not long after its launch in November 2019, as it crept in at barely 100 miles. Quote, "We view this behavior as unusual and disturbing. It has the potential to create a dangerous situation in space." According to Raymond, the US government has reached out to Moscow through diplomatic channels to express its concern. This confrontation was the first time the US military publicly identified a direct threat to a specific American satellite. Similar incidents have happened in terrestrial encounters between Russian and US or Allied elements, such as close calls between soldiers, jets, and warships around the world. However, space might be a whole new theater for unintentional escalation of hostilities. The Pentagon, the White House, and backers in the US Congress have argued that the incident demonstrated the need for a Space Force, which President Donald Trump established in December 2019 through the National Defense Authorization Act. This was the first new military service created since the Air Force in 1947. However, space warfare doctrine is still a work in progress. The Space Force would represent a strategic shift from passive observation to active defense. Raymond has reinforced the need to mobilize the Space Command against perceived threats, given that Russia and China are developing an increasingly sophisticated arsenal of space weapons and craft that would render the US vulnerable in space. But further actions would involve high costs and potential budgetary sinkholes. The Russian move and the Pentagon's response may as well be a new front in the effort to assess real and potential threats while avoiding costs. William D. Harding, director of the Arms and Security Project at the Center for International Policy, expressed, quote, "The initial costs of setting up the Space Force are likely a small down payment on an undertaking that could cost tens of billions of dollars in the years to come. The last thing we need is more bureaucracy at the Pentagon, but that's exactly what the Space Force is likely to give us. Creating a separate branch of the Armed Forces for Space also risks militarizing US space policy and promoting ill-advised and dangerous projects that could involve deploying weapons in space." The Russian embassy has not responded to requests for comments on the alleged threat, but the Kremlin has reassured that the satellites are not weapons, but merely inspector spacecraft orbiting as part of an experiment. The NRO has also refused to comment on the KH-11s, their mighty Hubble Space Telescopes that are not gazing at the vastness of space, but looking down at the planet and focused on foreign top-secret military installations. The 4 satellites operate in polar orbits above the rotating globe, covering its entire surface. One KH-11, known as USA 224, is believed to have taken the famous picture of Iran's Imam Khomeini Space Center posted by President Trump in August of 2019. The image is so sharp that the Farsi characters written on the edge of the launch pad are visible. Thompson used publicly available data to speculate about the happenings and intentions behind the American satellite. Quote, "The relative orbit is actually cleverly designed, where Cosmos 2542 can observe one side of the KH-11 when both satellites first come into sunlight, and by the time they enter eclipse, it is migrated to the other side." General Raymond further expressed his concern, quote, "In 2017, they launched a satellite. It launched another satellite. The satellites exhibited characteristics of a weapon system, where one of those satellites launched a high-speed projectile into space. In 2018, the US raised the issue at the UN Conference of Disarmament, warning about Russia's troubling behavior. Still, there were no specifics, and Moscow's intentions remain unknown. Former Air Force officer and expert in space security at the Secure Worlds Foundation, Brian Wheaton, speculated that the Russian satellite's position could help determine where the US satellite is pointing, and quote, thus what ground targets it's taking pictures of, as well as the general operating schedule and usage. Moreover, if Russian satellites are equipped with electronic emission probes, they could listen to radio frequency signals and figure out how the KH-11s communicate, while potentially intercepting those likely encrypted messages. Todd Harrison, director of the Aerospace Security Project at the Center for Strategic and International Studies, stated that, quote, there are a lot of things it could be doing. It could simply be practicing on-orbit maneuvers or signaling to the United States that they have this capability. The Keyhole program is nearly half a century old, and it is no secret that satellites have similar capabilities as the Hubble telescope. Russia was probably showing that it's now part of the club of nations that already have the ability to launch spacecraft into close orbit, such as the US and China. Raymond added that, quote, it's clear that Russia is developing on-orbit capabilities that seek to exploit our reliance on space-based systems that fuel our American way of life. His standpoint is that the close inspection of a foreign satellite is virtually indistinguishable from staging an attack. Still, despite the science fiction-like space weapons invented in the last decade, thousands of satellites are actually used for non-military purposes, and several developed nations depend on satellites to enable everything from commerce and banking to transportation and communications. Raymond concluded that, quote, we prefer space to remain free of conflict. We think that responsible spacefaring nations need to have conversations about developing those norms going forward. The mutually assured destruction doctrine once proved enough for the superpowers of the world to step back, while a series of treaties and open lines of communication were put in place to avoid accidental escalation of conflict. Still, the US, Russia, and other countries have yet to create an analogous diplomatic protocol for space matters, and experts warn about the dangers of weaponizing spacecraft without it. The KH-11 does not have any known defensive weapons, but as Thompson put it, there's not much the NRO can do about the nosy spatial neighbors, quote, besides grumble at the UN.